Hi guys, this is a calculus video, midterm points back, step 6. I'm going to be referring so have your midterm in front of you, midterm part C in front of you, and so you could follow along, and I'm going to do this problem, and I'm going to explain my thinking very thoroughly, and I'm also going to be referring to this packet, so have that in front of you, please. And then I'm also going to be referring to the AP scoring guidelines for this exam, the exam that this was taken from. So I won't keep showing you this over and over. I'll just keep referring to it from off to the side. But this I'll show you from time to time. So, okay, I already started this video and then I made an almost immediate mistake and had to start all over. So that's why this is written here. So a particle moves along the x-axis so that its velocity at time t is given by this function here. At time t equals 0, the particle is at position x equals 1. So what they're telling me here is that x of 1, if you're letting x be the position function, x of 1 equals 0. And then I'm just off to the side. You don't even have to do this like on your paper, but this is my thought process. So off to the side, I'm making the observation right away that the derivative of this is the velocity function. So where x prime of t equals v of t. That might come in handy later. So part A, find the acceleration of the particle at time t equals 2. Is the speed of the particle increasing at time t equals 2, why or why not? So for part A, we want the acceleration at time, we want the acceleration at 2, and this is v prime of 2, all right? And so now I'm going to go to my calculator. It's a calculator section. Before the midterm, guys, I didn't even show you this feature, so a lot of you were trying to find, probably you were on the right track. You were trying to find the derivative of velocity by hand maybe, and that probably tripped you up. You would have needed chain rule and product rule. It would have gotten messy, but now that I've shown you this, we can just go math 8. Okay, so d dx, and then I plug in the velocity function, so negative. And you want to use this feature whenever you're allowed to use a calculator and you're finding the derivative at a certain point. Okay. Oh, darn it. X equals 2. Okay, so right there. And I'm looking at the scoring guidelines and they want 3 decimal places. Okay, I've been telling people like 4 or 5, but looks as though they want 3. So 1.588. Okay, so we have found the velocity. Oh, let me tell you as we do things, never mind, I'll tell you at the end. Okay, so there's that. Now, when they ask us, is the speed of the particle increasing at this time, we need to be thinking of Susan's table. Okay, so actually I should have referred to that already. So number 4 on that packet that's off to the side, derivative graphs, Susan's table. If you knew that table, you would know that a particle is speeding up if both its velocity and acceleration have the same sign, so either both positive or both negative. It'd be slowing down if they had opposite signs. So I know that the acceleration at time 2 is positive, but now I've got to see if the velocity at time 2 is positive or negative. So I'm going to go velocity at 2. Okay, and I'm just plugging it in. I'm plugging 2 into the velocity function, so I'm going to get negative 3, and then sine of, I'll end up with 2, because 2 squared over 2. Okay, so right there, so the velocity at time 2 is negative 2.728. So the verdict is that, is the speed of the particle increasing? No, the particle is slowing down. Maybe I'll say that. Is slowing down because, maybe we should write out because the acceleration at 2 is greater than 0 and the velocity at 2 is less than 0. Okay, now I'm done with the problem. And then let's look at the scoring rubric and see what they say and how many points I got. Okay, so they wanted us to find this. Oh, they even showed the way that I did. That a of 2 equals b prime of 2. And then they got those numbers. Okay, so there's more work. Okay, we got a full 2 points. This section was 2 points. We got the acceleration at time 2. So just, yeah, so we got that. And then we said speed is decreasing or no to their question with a reason. Okay, so part B. Find all times in the open interval 0 to 3 when the particle changes direction. Justify your answer. Okay, so B, you will need to know, and this is from the Susan's Table physics version section of our packet, you need to know that a particle changes direction when its velocity changes sign. So we've got to do a sign test on velocity. So so if I want to do a sign test, first I'll find out where the particle's at rest, okay, because it would have to be at rest. Well, I'm looking at this time interval, 0 to 3, okay, and I want to find out at what time within this interval. Okay, so this is going to be velocity. Okay, and then those are values of t. And I'm trying to find at what value between here I maybe change direction. So first I'll find out where I'm at rest. So where is velocity 0? So I need v of t equals 0. This is a calculator section. So I'm going to go right to my calculator, and I think I've already done this. I type in the velocity function, okay? I'm concerned with it on this interval from 0 to 3. So I go to my calculator, 0, or my window, 0 to 3. I'll do the y min and max -3 to 3. And then graph. Okay, this is the graph of the velocity function. So this is the first derivative of position. The graph of the velocity function. I'm figuring out where it's 0, and right there's only one point where it's 0, and it actually will change direction here because velocity goes from negative to positive. So how do I find that 0? I go second calc, intersect. Oh no, I don't. I go second calc, 0, my bad. Okay, left bound, enter. Right bound, enter. Enter again, okay? So we've got, so t equals 0, then t equals 2.507. Alrighty, now I had to abbreviate that, and 3 decimal places is good enough for them, but these free response problems, they tend to have like a sequence where, you know, where like the problem you're on, the part you're on could rely on an answer up above it. So I have a pretty good sense that I might be using this again. So I'm going to go to my home screen. All right, I type in x. Notice right there, that's the x coordinate that I just found. Okay, your calculator will understand that. And I'll store it under a different letter. So I'm storing it under A, okay? So whenever, okay, so if I want to use this number again, I can just use A for it. And I won't, you know, I'll have a better approximation. Okay, so find all times in the open interval when the particle changes direction, justify your answer. Okay, so now I don't know that it changes, or actually I do know that it changes direction because I just saw its graph. So 2.507. When we looked at the graph on my calculator, it was below the x-axis here, so it was negative. It was above the x-axis there, so it was positive. All right, so my answer is when the particle, okay, I'll say the particle changes direction at t equals 2.507 because at this point, or at this time, velocity changes from negative to positive. Alrighty, so that was part B, and let's see what the rubric says. Okay, so they set velocity equal to 0. If you didn't use your calculator, you would have gotten this exact answer, but this was fine too. And then they say this. Okay, so read that. And then we would have gotten the 2 points because we have this part. So you get 1 point if you just said this only, but we would get 2 points because we had a justification. So there's that. Now, actually, when I did this earlier, C and D are not that bad, guys. But, I mean, they are hard in the sense that you really need to know these formulas that I'm about to use. And if you don't know the formulas, you won't be able to do them. But if you know the formulas, they're really, I feel like C is the easiest. And that's just funny because usually they get progressively harder. And again, if you didn't know the formula, it would be very hard. Find the total distance traveled by the particle from time t equals 0 until time t equals 3. You need to know the total distance formula, which is this. And what goes inside of there, if we want the total distance, then I'm going to plug in the absolute value of velocity. Okay, displacement or net change in position would be not the absolute value, but this is the total distance formula. So I'm just going to use it. Okay, so from A to B, the absolute, from 0 to 3, sorry. From 0 to 3, V of t, okay, and then I just plug it into my calculator. So math 9, 0 to 3, math over, that's absolute value, and then I plug in the velocity function. Sine. I feel like I'm going wicked slow. I'm tired, guys, sorry. I'm just waiting. Yes, oh, duh, it's right there. Okay, so it's 4.334. 4.334. Guys, no explanation, no nothing. They just asked us to find it. But interestingly, so I feel like this was the shortest part. So you needed to say this. And then this is a 3-point part. So even if this was all you knew how to do, you'd get 3 points right here. We have the limits of integration. So 0 and 3. We have the integrand, which is the input of the integral. So we have the absolute value of velocity. And then you get a point for the answer. So if you didn't do the other two, but you just said the answer, you'd get at least 1 point. Okay. And now part D. During the time interval, 0 to 3, including 0 to 3, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. Okay, so guys, you know what I'm going to do? I'm just going to find the position of the particle at times that are important within this interval. So, yeah, so you would need to know the antiderivative with an integral formula, the antiderivative with an integral formula, because, so we want, okay, so for example, all right, I'll find, all right, so x of t is position. Okay, so I'll say that. We would need, all right, and this is equal to, no, never mind. So this is the antiderivative of velocity, but you don't know how to find the antiderivative of this function. You can't do it. It will not work. We have no techniques for it. We have no definitions for it. So you need the antiderivative as an integral, or with an integral formula. And it goes like this. It goes x of t equals x of a, okay, where a is some number that I know the output for, plus the integral from a to t. Okay, that's where the input of this function goes. And then here I do x prime of, I'll say p, dp. All right, these numbers cannot be the same as ones that have appeared, or these variables can't be the same as the ones that appeared before it. So I can find the positions. So the velocity, okay, at time t equals 0, I'll figure out where I am at that moment. Then I move left, 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 or the particle does, and then stops at this point here. So this would be a good point. This would be a good time to know the position at. Because from here, it's just going left, 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 left. And then here, it's the furthest left that it's going to be. And then I go right, 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 right until time t equals 3. So I'm going to find the positions here, here, and here. And then I can just say, oh, which is furthest from the origin. So and I'll use this function. If you didn't write this down to begin with, that's okay, guys. If you don't know how to do, if you do know how to do what I'm about to, you're good. All right, so x of 0, guys, they told us that was 1. All right, at the very beginning I wrote it down. Now I want x of I'll say 2.50 dot dot dot. Okay, and then I'll tell my reader maybe that this is stored as A. Okay, that's stored as A in my calculator. All right. And then so this is going to be equal to, I know x of 0, so right there, so I can go x of 0, which is 1, plus the integral from 0 to a. All right, so those inputs have to be the same. And then I just do x prime is velocity, so I go v of p dp or something like that. Okay, I'm just using the formula as I wrote it up there. Okay, so in my calculator, I go math 9, from 0 to a, and then the velocity function, so negative x plus 1 sine 2. I forgot to add 1, so I'm adding it at the end. Okay, and I got negative 2.265. Okay, so right now it's further from the origin at this time than it was at the beginning. Okay, at the beginning it was only 1 unit from the origin. Now it is 2.265 units from the origin because it's located at that point. Now let me check 3. Okay, x of 3, same thing. 1 plus the integral from 0 to 3. All right, so I just do, I can just go second enter, back up. Oopsie. Ah. Why can't I? Oh, there we go. Okay, to 3. And negative 1.197. And then the question was, during that time, what's the greatest distance between the particle and the origin? During the time interval, what is the greatest distance between the particle and the origin? To the greatest distance between particle and origin is, remember, distance is positive. Okay, because at this time it's 1 unit from the origin. At this time it's that many units from the origin, but positive because this is positive. And then this one, that many. Yeah, so there's that. Okay, guys. I hope that you were able to watch this at home so you could go fast. Let me just show you this. All right. So here's the answer. They give a little explanation, but you don't have to with, they weren't asking for it. So you get 1 point for plus or minus the distance. So, yes, you just get 1 point for plus or minus distance particle travels while velocity is negative. Okay, so I didn't have to find all of them. And then the answer. Alrighty, guys. So, there's that. And I will see you later. Bye-bye.